Welcome to today's Explainer. We're going to build a highly practical, absolutely bulletproof mental model for securing your smart contracts. We are mastering Solidity's function visibility modifiers. So if you've ever wondered how to lock down your code while simultaneously saving on gas fees, you are in exactly the right place.
Before you write a single line of logic, this is the ultimate question you have to ask yourself. In smart contract development, where code is immutable and transactions are completely final, controlling exactly who can trigger your functions isn't just some nice-to-have best practice. It literally dictates your contract's core security and its operational cost. Here's our roadmap for today. 1. Principle of least privilege. 2. Public, widest access. 3. External, the outside world. 4. Internal, family privileges. 5. Private, strictly hidden. And 6. The decision tree. Let's dive right in.
Section 1. The principle of least privilege, securing the perimeter.
In Web3, your function visibility really is your first line of defense. If you're coming from traditional backend languages like Java or TypeScript, you'll know this as access control. The principle of least privilege means you're strictly minimizing your contract's attack surface. You absolutely never give a function more access than it needs to perform its exact job securely. It's that simple. According to a great breakdown from IIT Kanpur, we basically have 4 visibility choices to work with: public, external, internal, and private. Let's take these 4 building blocks and turn them into a practical, actionable decision tree that you can use every single day.
Section 2. Everyone accesses it. Public.
Let's start right at the top of our funnel with the most inclusive modifier. When you mark a function as public, you're quite literally opening your doors to the entire world. Think of it like a company's main public phone line. Anyone can call it. This means external users, third-party smart contracts, and even other internal functions within your very own contract can execute this logic.
So here is the crucial point for this first branch of our decision tree. Need everyone to access it? Go public. But remember, with great accessibility comes great responsibility. You have to ensure these functions are flawlessly secure because they are exposed to absolutely everyone.
Section 3. Outside world only. External.
Restricting access just a bit, think of an external function exactly like a doorbell on your house. It's designed to only work when someone standing outside presses it. External functions cannot be called from inside your own contract. In fact, if an internal function tries to call an external one without using a really gas-heavy trick, the Solidity compiler will actually throw an error and stop you in your tracks. So, here's the second branch of our decision tree. Only users and other contracts? Go external. If it's strictly for the outside world, this is always your go-to modifier. Now, you might be wondering, why not just use public for everything outside? Well, here's the hidden mechanical advantage: gas efficiency. When a public function receives an array, it has to copy those arguments into expensive temporary memory just in case an internal function decides to call it. But an external function? It knows it will never be called internally, so it reads those large arguments directly from a super cheap read-only space called call data. Choosing external over public for large inputs will literally save your users money.
Section 4. Family privileges, internal.
Now we cross the boundary, completely closing the door to the outside world to focus purely on internal logic. The internal modifier is kind of like the family room of your house. Outsiders aren't allowed in. Only your contract and its kids, meaning derived contracts that inherit from your base contract, can access this logic. If you're an object-oriented programmer, this is basically identical to the protected keyword.
Which brings us to step 3 of our tree. Helper functions shared with child contracts? Make it internal. If you're building a foundational tool that inheriting contracts need to share or override, internal is exactly where you want to be.
Section 5. Strictly hidden, private. Finally, we hit the bottom of our funnel, the absolute most restrictive level of access control available in Solidity. If internal is the family room, private is a locked safe inside your bedroom. Only the exact specific contract that declares this function can see it or use it. It is completely walled off. Even your own derived child contracts are strictly locked out here. So, for the final branch of our tree, helper function only this contract should use, make it private. If you have highly sensitive logic that you absolutely do not want child contracts manipulating or even touching, lock it down. Apply that principle of least privilege to the max. Mechanically, the only real difference between internal and private is inheritance. But listen, I have to highlight a massive security warning here. Making a function or a state variable private restricts code execution, but it does not hide the data from the public blockchain. Anyone analyzing the chain can easily read the raw data in your private variables. Never, ever store passwords or unencrypted secrets on-chain, regardless of the visibility modifier you use.
Section 6. The Visibility Decision Tree.
Okay, let's pull all these concepts together into a clean, actionable checklist. Run this simple 4-step process every single time you write a function. Need everyone to access it? Map to public. Only users and other contracts? Map to external to save gas. Helper function shared with child contracts? Map to internal. Helper function only this contract should use? Map to private. If you picture a cheat sheet matrix of access rights, it all clicks into place. Public gets a yes everywhere. External is a yes only for external calls. Internal opens things up to derived contracts, and private remains an isolated yes purely for internal use within that exact contract. It's a perfect system once you internalize it.
Keep in mind that some of the most common, and frankly, devastating, beginner exploits in Web3 trace back to just a single missing or incorrect visibility keyword. Imagine accidentally leaving an administrative helper function set to public instead of private. You've essentially just handed over control of your entire contract to the internet. I want to leave you with this provocative thought today. Go look at your existing code. Check your function signatures. Are your smart contracts currently leaving the front door wide open? Are you defaulting to public everywhere when external could be saving your users precious gas? Could dropping a function down to internal or private save you from a future exploit? Remember, applying the right visibility isn't just about making the code compile. It's about writing professional, secure, and optimized smart contracts. Thanks for joining me on this explainer, and I'll catch you in the next one.